All right, in this lesson, we're going to start Chapter 6, Section 2A, which is right triangle trig. We're going to expand on some things that you learned last year in geometry, and then we're going to do a little bit newer stuff involving the stuff that we learned this year in this lesson. All right, so basic right triangle trig, I'm sure you guys remember SOHCAHTOA, right? And this is basically saying, it's a little mnemonics that you guys can help, so that you guys can remember what the trig ratios are. And we have that so sine of theta and angle is equal to the opposite side over the hypotenuse. All right, this part of it is going to be cosine of your angle is adjacent over your hypotenuse. All right, and then TOA is going to be tangent of an angle is the opposite side over the adjacent. All right, stuff that you guys learned last year in geometry, right? So I'm going to rewrite all of these right here. All right, but then you see on the side, we have some new stuff, right? We have a cosecant, a secant, and a cotangent, right? So these are new, right? This is what separates the stuff that you're learning in this year from what you learned last year in geometry. Now, in geometry, you should be able to do sine, cosine, and tangent of a triangle and find the trig ratios easily, right? But here, what you should know and what's new is this cosecant, secant, and a cotangent, right? So what you should remember is that sine is going to go with cosecant. The abbreviation for it is going to be this CSC. So CSC of an angle, theta, is going to be the reciprocal of sine. If sine is opposite over hypotenuse, then cosecant is going to be hypotenuse over opposite. All right, similarly, secant goes with cosine, right? And this abbreviation is going to be SEC, right? So secant of theta is going to be the reciprocal of cosine, right? So this is going to be a hypotenuse over adjacent. And then similarly, cotangent is going to go with tangent, and it's going to be the reciprocal of that, right? So if tangent is opposite over adjacent, then cotangent is going to be adjacent over opposite. All right, cotangent is pretty easy to remember because it goes with tangent, right? Secant and cosecant, a lot of people mess up. You would think that they would match, right? So you would think that because this one starts with an S and this one starts with an S that they would match, right? But it's actually not the case. If this one starts with an S, then you want it to switch, right? Because the whole idea here is that you're flipping it and you're taking the reciprocal. So if it starts with an S originally, then we don't want it to start with an S in the other trig function, right? And then here, if I have cosine that starts with a C, you would expect it to start with a C also with cosecant, but no, right? You want it to flip and you want it to be the other one, right? If it's the reciprocal, right? So that's one way to remember it, but otherwise, that's maybe the hardest thing that you have to remember here. All right, now this is what I had just said in the previous slide, but in different terminology, right? So we're basically saying that sine, cosine, and tangent are the reciprocal of cosecant, secant, and cotangent, respectively. Right, and it works in any direction. If I give you, for example, cosecant, and I want you to find sine, all you have to do is take the reciprocal of cosecant to find sine. Right. Similarly, if I give you sine and I want to find cosecant, you just have to find the reciprocal of sine, and then you get cosecant. All right, but that's all this slide is saying. All right, now let's apply this knowledge to a problem. All right, so in this problem, I want to find the 6 trig functions. We typically give you an angle. I'm just going to call this our angle, right? I'm going to call this one theta. All right, so to find the 6 trig functions of theta. All right, now with sine, cosine, and tangent, I know SOHCAHTOA, I need an opposite, a hypotenuse, and an adjacent. All right, I have an opposite. All right, so I'm going to call this my opposite. I have an adjacent. And then I need a hypotenuse, right? So a hypotenuse is going to be across from this right angle. If you only have 2 sides, what you have to do is use a Pythagorean theorem, right? So if you remember, a squared plus b squared equals c squared to get the missing side, right? So I'm going to pick, it doesn't really matter which one you label as long as c is your hypotenuse, right? 7 and 24 are both legs, so I can just label them. It doesn't really matter if they're a or b. All right, so I get 7 squared plus 24 squared equals c squared, right? And so that gets you 49 plus 576 equals c squared. And this gets you 625 equals c squared. And then I want to square root both sides, and so you get c equals 25. Right, so my hypotenuse is going to be 25. And now you can use SOHCAHTOA, right? So I want to find sine, cosine, and tangent of my angle. Right, so remember, sine is always going to be your opposite over your hypotenuse. Right, and my opposite we said is 24. And then your hypotenuse we just found is 25. All right, so that's your value for sine. Now cosine, I know that that's my adjacent over my hypotenuse. And then my adjacent is 7. My hypotenuse is 25. So this is our value for cosine. And then for tangent, right, similar story, I have an opposite over adjacent. And my opposite, I know that that's 24. My adjacent, I know that that's 7. All right, and now we have new functions as well, right? We kind of talked about in the first slide of this lesson, cosecant, secant, and tangent, right? Remember, sine is going to go with cosecant. All right, so cosecant, we said that that is the reciprocal of sine, so it's not going to be opposite over hypotenuse, it's going to be hypotenuse over opposite. All right, so essentially what we do is we take the numbers and we flip them, right? So it becomes 25 over 24. All right, and then we do the same thing for secant. All right, secant is going to go with cosine, so that's going to get you adjacent, no, I'm sorry, not adjacent, hypotenuse over adjacent, right, the reciprocal of cosine, which is just going to be the flip of what we have, so 25 over 7. And then cotangent is going to go with tangent, and that's just the reciprocal of tangent. So it's going to be adjacent over hypotenuse, over opposite. And that's going to get you 7 over 24. All right, so that's how we do all of these kinds of problems. All right, once again, I want to find the 6 trig functions of theta. All right, so we'll just write that, of theta. And I'm going to use the same respective angle, right? So I'm going to say that this is theta. I have here an opposite, and I have a hypotenuse, right? So I'm going to label this as my opposite. This is my hypotenuse. I don't have an adjacent, right? To find an adjacent, I want to use Pythagorean theorem, right? So I'm going to do 1 squared plus b squared equals 2 squared, right? And I label it in this way because I know 2 is my hypotenuse. That has to be alone, right? And so we get 1 plus b squared equals 4. Subtract 1 on both sides, and so you get b squared equals 3. Square root 3 on both sides, and so you get b is the square root of 3. All right, I'm only going to use the positive. I know I kind of skipped over that in the last slide, but I only use the positive one just because you can't have a negative side measurement, right? So I'm just going to keep the positive one. Now we do the same thing that we did before, right? I want to find the 6 trig functions. I'm going to start simple with sine, cosine, and tangent. All right, so sine, once again, I know that that's opposite over adjacent. Opposite over hypotenuse, which is going to get you 1 over 2. All right, cosine, I know that that's going to be my adjacent over hypotenuse, which is a square root of 3 over 2. All right, now tangent is going to be opposite over adjacent, all right, which is going to be 1 over the square root of 3, but keep in mind we can't have a square root in the bottom. So I'm going to multiply the top and the bottom by the square root of 3 to rationalize it. So we get the square root of 3 over 3. All right, and then we want to do the same thing that we did in the previous slide, and I want to get cosecant, secant, and cotangent. Right, so cosecant is the reciprocal of sine, so it's going to be hypotenuse over opposite, which is going to be 2 over 1 which is just 2. All right. And I do the same thing with secant, right? I know that that's the reciprocal of cosine. So that's going to be 2 over the square root of 3, but once again, I can't have a square root in the bottom. So I'm going to rationalize it. Multiply the top and the bottom by the square root of 3, and you get 2 square root of 3 over 3 as your value for secant. Right, and then I want to do the same thing with cotangent. Right, I know that that's going to be adjacent over opposite. My adjacent is square root of 3, and my opposite is 1, right? So square root of 3 over 1 is just the square root of 3. Now, you could have taken your simplified version of tangent and then took the reciprocal of that, but that would give you a little bit more to simplify, right? So I would just use the measurements that you see in the original diagram and then simplify from there if needed, so that you don't have to do any sort of unnecessary simplification. All right, so we're going to continue this topic just talking about special right triangles. Now, this is another thing that you've seen in geometry last year, right? So there were 2 kinds of special right triangles, right? We had a 45, 45, 90, and then we had a 30, 60, 90. All right. Now, the special thing with the 45, 45, 90 triangle, right, any isosceles right triangle is going to be a 45, 45, 90, right? So if this is 45, then this is also 45, meaning that these 2 legs are congruent. And then the hypotenuse, the special thing about the hypotenuse is that it's the length of the legs times the square root of 2, right? So you can generalize it with any side measurements, right? So if in general I usually call this A, some teachers, depending on who you had last year for geometry, might have used S, right? It doesn't really matter. I use A, and then that means this side measurement is going to be A square root of 2, right? If I give you another right triangle right down here, and this is a 45, 45, 90, and I give you that this measurement is 8, right? Then I know that this measurement is also 8, and then I know that this hypotenuse is going to be 8 times the square root of 2, right? And you can go backwards as well, right? If I give you another triangle right here, right, an isosceles right triangle, so it's a 45, 45, 90, and I give you that this hypotenuse is 10 square root of 2, then all I have to do to find my legs is to just divide 10 square root of 2 by the square root of 2, and then you get 10 and 10. All right, so that's what's special, right, about this special right triangle. The other special right triangle that you guys learned about last year was this 30, 60, 90 triangle, right? We have another rule here where the shorter leg, in this case it's 1, so again, sometimes you call it A, sometimes you call it S, maybe you use X, right? It doesn't really matter. The shortest length I'm going to call A, and then the second shortest side, or I guess the longest leg, right, is going to be whatever the shorter leg was times the square root of 3, right? And then the hypotenuse is going to be 2 times the length of the shortest leg, right? So everything relates to the side across the 30 degrees, right? So if I give you, let's say, right, that this is 30, and then this is 60, right? So if I give you this side measurement is 8, right, that's the shortest leg, right? So then the longest leg is going to be 8 times the square root of 3, and I know that my hypotenuse has to be 2 times 8, which is 16. Similarly, if I give you, right, this is a 30, 60, 90 triangle, right, and I give you that this measurement is 20, right, that's the hypotenuse. I know that the hypotenuse is double the length of the shortest leg, right? So that means this side across the 30 is going to be 10, right? Because 20 divided by 2 is 10. And then I know that the length across the 60 is going to be 10 square root of 3. All right, similarly, if I gave you the side across the 60, all right, so if I give you that this is 60, 30, and I give you that this is a 7 square root of 3, right? I know that to find the length of the shortest leg, all I have to do is divide the 7 square root of 3 by the square root of 3. and then you get that this is 7. And then from there, you can find the length of your hypotenuse. It's just 7 times 2, which is 14. All right? So a couple different ways that you can find all of your sides, right, without having to do Pythagorean theorem all the time, or without having to always plug it into your calculator, right? And this is going to be useful not just in this lesson, but you guys are going to see later on after your test that we're going to do a lesson that this is going to make a lot more sense. All right, so we're going to find the following trig functions for 30 degrees, 60 degrees, and the slide after this is going to be for 45 degrees, right? So I'm going to start with 30 degrees. I know that 30 is the angle measurement of a special right triangle, right? So I'm going to draw this triangle on the side. All right, so I'm going to say that this is 60 degrees. I'm going to say that this is 30 degrees. All right, and then I have my right angle right here. So it doesn't really matter what we call this, right? So I'm going to say that this is just any measurement. I'm going to say that the side across the 30, I'm going to use what was on the previous page, and I'm just going to call it 1. Right? If this is 1, that means the side across the 60 is going to be 1 times square root of 3, which is just the square root of 3. And then that means the hypotenuse is going to be 2 times 1, which is just 2. Right? So the first example here, I want to find sine, cosine, tangent, cosecant, secant, and cotangent of 30 degrees. That means this right here is going to be my angle, right? So this right here, my 30. That means comparing everything to this 30 degrees, this 1 is going to be my opposite, right? The square root of 3 is going to be my adjacent, and this 2 is going to be my hypotenuse, right? So then I'm just going to do exactly what I did in the other examples, just using these side measurements. And keep in mind, you can really use any measurements that you want as long as you simplify your answer at the end. So let's say instead of using 1, square root of 3, and 2, I used, I don't know, 5 square root of 3, and 10, right? If it's a special right triangle, then these are going to hold true regardless of what the side measurement is. I think in class with one of the periods, I used A, right? So I drew a triangle, and I said 30, 60, right? I called this A square root of 3, and 2A. And then I simplified from there, right? It doesn't really matter, right? I'm just going to use 1, square root of 3, and 2 because those are the simplest that you're going to see. All right, so sine of 30, I know that that's opposite over hypotenuse. Right, so this is going to get you, my opposite is 1, and my hypotenuse is 2. All right, now cosine of 30, that's going to be adjacent over hypotenuse. And my adjacent is the square root of 3. And then my hypotenuse is 2. All right, tangent of 30 is going to be opposite over adjacent, so 1 over square root of 3, but once again, I can't have that as my answer. I need to multiply the top and the bottom by the square root of 3. So this is going to be the square root of 3 over 3. All right, and then these are for sine, cosine, and tangent. Now cosecant, secant, and cotangent, you just need to know that those are the reciprocal of trig functions that you already found, right? So cosecant is going to go with sine. That's going to be my hypotenuse over opposite, which is going to be 2 over 1, which is just 2. All right. Secant is going to be hypotenuse over adjacent. I know that that's going to be 2 over square root of 3. And then again, I can't have that as an answer, so I need to multiply the top and the bottom by the square root of 3. So I get 2 square root of 3 over 3. All right. And then cotangent, again, is going to be adjacent over opposite. Right, so that's going to be square root of 3 over 1, which is the square root of 3. All right. Now, these are actually values that we found before, right, in the second example that we did in this lesson. All right, so we did these already. Now let's try the same thing. Let's use the exact same triangle, right? So I'm going to use this triangle that we drew for that example, and I'm going to use that same thing to find the same trig functions for a 60, right? So now I'm actually going to redraw it so that way it's a little bit cleaner, right, to look at, right? So I'm going to draw the same triangle, all right? I'm going to have the same angles, right? Everything is labeled exactly the same. all right? And this is going to be 1 square root of 3 and 2, right, since it's a 30, 60, 90. Only thing now is that now the side across from the 60 is going to be my opposite, right? So square root of 3 is opposite. All right, 1 is going to be my adjacent. All right, and then 2 is going to be my hypotenuse. All right, so let's do the exact same thing, right? Sine, I know that that's opposite over hypotenuse. So that's going to be the square root of 3 over 2. Cosine of 60, that's going to be adjacent over hypotenuse, which is 1 over 2. Tangent is going to be opposite over adjacent, which is the square root of 3 over 1, which is just the square root of 3. Right, now do the exact same thing with cosecant, secant, and cotangent. Cosecant, I know that that's now hypotenuse over opposite, right? It's the reciprocal of sine, so it's going to be 2 over the square root of 3, and then multiply the top and the bottom by the square root of 3 to rationalize the denominator, and then you get 2 square root of 3 over 3. Right, secant of 60 is going to be the reciprocal of cosine, so 2 over 1, which is just 2. All right, and then cotangent is going to be the reciprocal of tangent, right? So adjacent over opposite, so 1 over the square root of 3. But once again, that can't be an answer, so I'm going to multiply the top and the bottom by the square root of 3. And then these are my 6 trig functions. Notice what happens going from one to the other. Notice that everything's basically flipped, right? So what was the value for sine became the value for cosine, right? And then what was the value for cosine became the value for sine. All right. So that'll happen when you are going from one angle to another in a right triangle, right? And that's maybe a property that you learned last year in geometry, where, for example, if I have any arbitrary right triangle, right, and this is theta, right, then you know that, for example, cosine of theta is the same as if I did sine of 90 minus theta, right, in degrees, right, because these make up 2 parts of the 2 angles, the 2 acute angles of a right triangle, right, sorry, which is a property that you learned, right, but if you don't understand that, don't worry too much about it, as long as you can draw a triangle, right, and label it appropriately, and you know SOHCAHTOA, then this shouldn't be anything super crazy. All right, so we're going to do the exact same thing now with 45 degrees, right? So I'm going to draw my 45, 45, 90 triangle, right? A 45, 45, 90 is an isosceles, right? So that means this side is the same as this side, which are both going to be 1, right? So I'm going to write a 1 and a 1. And then this hypotenuse is going to be 1 times the square root of 2, which is the square root of 2. Again, label it however you want, right? Pick a random side if you want to. If 1 is kind of difficult, just pick, I don't know, 5, 3, right? You can make an arbitrary one, right? A square root of 2, right? So it doesn't really matter as long as your answer is fully simplified, right? It won't make a difference. So I'm going to do the same thing, right? I'm going to say this one right here is my angle, right? And you'll see that it doesn't really matter. If this one's 45, then this one's also 45, so it doesn't really matter. So I'm going to say sine of 45 is opposite over hypotenuse, which is 1 over the square root of 2, and then again, rationalize. All right, always make sure you're rationalizing is going to get you the square root of 2 over 2. All right, now cosine of 45, adjacent over hypotenuse, is going to be 1 over square root of 2. Same exact thing, right? Rationalize. And then we get the exact same answer, right? Square root of 2 over 2. Now tangent is going to be opposite over adjacent, so 1 over 1, which is just 1. All right, and then to find cosecant, secant, and cotangent, I'm just going to take the reciprocal, right? So it's going to be square root of 2 over 1, which is just the square root of 2. Secant, again, is just the square root of 2 over 1, which is the square root of 2. And then cotangent is the reciprocal, so 1 over 1, but that's the exact same thing as just 1. All right, so these values actually work out pretty nicely, and it's important to know these for a 30, 60, 90 triangle, because later on when we get to the unit circle, you're going to see that these values are going to show up a lot. All right, so we're going to finish this lesson talking about reference angles. This might be the hardest thing conceptually, for you guys, right? Because there's a lot of different things to remember for these, but essentially it's the same exact skills as before, right? So depending on where the angle lies, right? The terminal side of an angle, wherever it is going to give you some distance between that angle and the x-axis, right? So for example, if I have an angle right here, right, this angle right here, it's already in the first quadrant. So my reference angle is just going to be my angle, right? But let's say I have one right here, right, in this quadrant, right? So I have an angle right here. Well, you have this angle, this is your theta, right? But your reference angle is going to be an angle that gets you to the x-axis. So to find this little bit, all you're going to do is you're going to do 180 minus your angle that you have, right? And you probably thinking, why are we doing this? It'll help us when we go to find trig values of angles that are bigger than what you see in a right triangle, right? Because notice, if I try to make a triangle using this as my angle, this one right here, then that's not really going to make a right triangle. But this angle right here, right, this little space right here is going to make a right triangle, which is a little bit easier to do than if you were to use the original angle, right? So there's ways around it. There's ways to make these problems a little bit easier, and reference angles is one way, right? So another thing that we do in the third quadrant, right, let's say I have an angle right here, right? Then instead of going all the way around and this whole thing is my angle, right? So this is my, I'm going to say that that's my angle theta. Well, the angle from, the distance from this angle to the x-axis is just going to be this little space right here, right? And then to find this is just going to be your angle minus 180 degrees. All right. And then in the fourth quadrant, right, so let's say I have an angle right here, right? Instead of going all the way around and saying that that's my angle theta, right? So this right here is my angle theta. The distance from this angle to the x-axis is going to be this little bit right here. And then to get this little bit, it's just going to be 360 minus your angle theta, right? So again, this might be the hardest thing conceptually, and right now it probably doesn't make any sense. But in the next slide, I'll show you where this is useful, right? So this is what I mean. To find these given values, right? Sine of 210, I can't draw that in a right triangle, right? I don't know what that's going to get you if you were to draw it out, because the total angles in a triangle are 180, right? And then 210 is already way bigger than that. But you can use a reference angle, right? So let's say I draw this in the coordinate plane, right? I would always draw here, right? So always draw. I'll even write it down so that you guys can see. Always draw. Always draw. All right. So now 210 is going to be, well, first, think about what quadrant that lies in, right? And that was the first lesson, right? That was in 6.1a. The quadrant that this lies in, well, it's going to be bigger than 180, right? But it's less than 270, right? Remember, our quadrants go from 0 to 90 to 180 to 270 to 360, right? All the way back around, right? 210 is between 180 and 270, so it's going to be somewhere right here. I'm going to say that this is 210, right? So 210 degrees, all right? But notice that if you connect this little segment, I'm going to say that this is a segment that ends right there. If I connect that to the x-axis, you get a right angle, all right? And then that right angle forms a right triangle where this is one of our angles, and then this angle right here, this is where our reference angle is useful, right? So to find this reference angle, that's just going to be 210 minus 180, right? If you remember from the previous slide, in the third quadrant, right? So this is in quadrant 3. In the third quadrant, we have that the reference angle is going to be the angle minus 180, which is going to get you 30 degrees, right? So really, we can use sine of 30 degrees. Just keep in mind, this is in a coordinate plane, so make sure your signs are accurate, right? Notice here, x is negative, and y is also negative, right? This is think of it like a point in the coordinate plane. And because this angle right here is 30 degrees, we can use the properties of a special right triangle to find this trig value, right? And then once again, opposite of the 30 degrees, I'm just going to call that 1. My hypotenuse, I'm going to call that 2. And then this measurement right here across this right here would be the 60, would be the square root of 3. Notice that this is in a coordinate plane, so these both have to be negative. So negative square root of 3 and negative 1. So then sine of 210, well, is going to be opposite over hypotenuse, which is going to be negative 1 over 2. All right, same value as if you were to get sine of 30, but since we're in the third quadrant, you need to be mindful of the signs, right? So since x and y are both negative, then our answer has to be negative. All right. So it might be a little bit confusing, but I'm going to try the same thing with another problem, and then hopefully you can kind of get the idea. Right, so let's try the same thing with tangent. Right, I have tangent of 300. Once again, I would always draw these. And then label, right, 0, 90, 180, 270, and then back around at 360. 300 is going to be in which quadrant? Right, notice that it's between 270 and 360, so it's going to be somewhere over here. I'm going to make it a segment so that way I can make a right triangle right here, and then this right triangle, we can find out the angles in it by using a reference angle. Right, so if this right here is going to be 300 degrees, right, a reference angle in the fourth quadrant, right, this is in quadrant 4, is going to be 360 minus 300, which is 60 degrees. And then notice that this also gives us, right here, our angle of 60 degrees, which gives us a special right triangle, right? I know that this right here is 30, and then I have a right angle, right? So this is a special right triangle, which we did before, all right? Now, the special thing about a special right triangle, a 30, 60, 90 triangle, is that the side across from the 30, I'm going to call this 1, right? Again, you can call it A, doesn't really matter, or any number that you want, just as long as you label the rest of them accurately. The side across from the 60 is going to be 1 times the square root of 3, and then your hypotenuse is going to be 2 times the shortest leg, so 2. All right, so then tangent of this, if my angle is right here, then opposite of this is going to be the square root of 3, and then my adjacent is going to be 1. So square root of 3 over 1. So the square root of 3. Keep in mind, this is going a little bit below, right? So if it's below the x-axis, that means our y-coordinate is negative, right? Remember that this exists in a coordinate plane. So I'm going to make my answer negative. All right? The signs also might be a little bit confusing. Right, keep in mind this is a coordinate plane. Think of it like x and y, right? This is the x-axis, then positive x's are over here, negative x's are over here. Positive y's are up here, negative y's are here, right? So be mindful of the signs. And I believe that this is another thing that I talked about in section 6.1a, all right? All right, so let's try the same thing with number 8, all right? So tangent of 675. This is a really big angle, right? And it's not going to fit in the 0 to 360 range. So to get it to fit in the 360 range, we can use a coterminal angle, right? So this is where another thing that we talked about is pretty useful, right? If you subtract 360 from 675, you're going to get 315. That's between 0 and 360, and that's a little bit easier to think about, right? So if I have a coordinate plane right here, this is x, this is y, and I want to label 315 degrees, well, I know 0, 90, 180 are labeled as follows, right? 270 and back at 360. I know that 315 is between 360 and 270. Right, so I'm going to draw that somewhere right here. And then this all the way around is going to be 315. All right, but again, that doesn't fit in a right triangle, but what does fit in this right triangle is whatever this little distance is, right? And this is going to be 45 degrees. How do you get 45 degrees? Well, it's in the fourth quadrant, so it's going to be 360 minus 315, which is 45 degrees. And then you can make a right triangle here. Keep in mind, this is a special right triangle, right? In a special right triangle, a 45, 45, 90, the two 45-degree sides are going to get you 1, 1, and then the hypotenuse is going to get you the square root of 2. All right? Keep in mind, think of it like a point in the coordinate plane, right? So if this is a point, the coordinates of this point are going to be x is 1, positive, and y is negative 1, right? So just be mindful of your sign there, right? This is going to be negative 1, all right? And then tangent, I know that that's opposite over adjacent. My opposite is negative 1. My adjacent is 1, so this is going to become negative 1 over 1, which is just negative 1. All right? Same exact thing with number 9. I have cosine of negative 240. Again, that doesn't really fit in our 0 to 360 range, so what I'm going to do is I'm going to add 360, right? Find a coterminal angle, right? And if you add 360, this is going to get you 120, right? 120 degrees, and that's a little bit easier to draw, right? So in the coordinate plane, right, x, y, I know that, once again, always label. I always tell you guys always draw. I'll also tell you always label. All right, and I know that 120 is going to be between 90 and 180, so that's going to be somewhere right there. All right, so this is going to be 120. Now to find this reference angle, if it's in the second quadrant, it's going to be 180 minus my angle, right? So 180 minus 120 is 60. That means the distance from this angle to the x-axis is going to be 60 degrees. All right, so then I can go ahead and draw my right triangle. And then because this is 60, I know that this right here has to be 30. This is a 30, 60, 90 triangle, right? And I can go ahead and label it as follows. So this is going to be 1 across the 30. Across the 60 is going to be the square root of 3. And my hypotenuse is going to be 2. All right, keep in mind, this is something like a segment on a coordinate plane. So I'm going to draw a point right here. Keep in mind the x right here is negative, right? Y is positive because it's above the x-axis. And then cosine is going to be my adjacent over hypotenuse. The adjacent to this 60 degrees is going to be this negative 1 right here. So this answer is going to be negative 1 over my hypotenuse is 2. Negative 1 over 2 is just, well, it's just negative 1 over 2, right? Negative 1/2. All right? So lots of things to be mindful of in this lesson. All right, so just be careful with, first, your signs, knowing which quadrant it's in, right? All of these things that I've mentioned before, right, didn't seem to have any use before, but they do have a use, right? So if you need extra assistance, go back to the other video, check and make sure you understand those lessons. All right, let's try the exact same thing in this slide, and then that'll be it for this lesson. All right, so I want to find secant of 210. All right, once again, I would draw it. Always, always draw it. I know that this is 0, 90, 180, 270, and then 360. Right, 210 is going to be between 180 and 270, so I'm going to draw that that's somewhere right here. Right, and I'm going to say that this right here is 210. And then to find a reference angle, keep in mind I can draw a little right triangle right here. And then to find this little angle right here, all I have to do is do 210 minus 180. And that's going to get you 30 degrees right here. All right. And then once again, this is a 30, 60, 90 triangle. Across this 30 is going to be a 1. Across this 60 right here is going to be the square root of 3. Across the hypotenuse is going to be 1 times 2, which is 2. All right, keep in mind this is also in the coordinate plane, so note which signs are positive and negative. And here, both x and y are both negative. All right, so then I'm going to go ahead and find secant of 210. Secant, remember, is the reciprocal of cosine, right? So this is 1 over cosine of 210. Or it's going to be, if cosine was adjacent over hypotenuse, this is going to be hypotenuse over adjacent. My hypotenuse here is 2 over, and then my adjacent to 30 is going to be this negative square root of 3, right? So I have negative square root of 3. And then once again, I want to rationalize this, so multiply the top and the bottom by the square root of 3. So we get that our final answer is negative 2 square root of 3 over 3. All right. Now we do the same thing with cotangent of 135. All right, once again, I would draw it. Right, I know that this is 0, 90, 180. I can stop there because I know that 180 and 90 is the interval range for 135. All right, so I know that 135 is going to be somewhere right here. And then the distance from this segment to the x-axis, right, is going to be 180 minus 135, which is going to get you 45. All right, so this theta right here, this is going to be 45 degrees. All right, and so that makes this a special right triangle. All right, so that means this 45 is going to be 1. This 45 is also going to be 1. And this hypotenuse is going to be 1 square root of 2. So just the square root of 2. All right, this is on a coordinate plane, so we need to be mindful of our quadrants. It's in the second quadrant, so x is negative and y is positive. All right, so then cotangent is just the inverse, I'm sorry, not the inverse, the reciprocal of tangent. All right, so if tangent is opposite over adjacent, then cotangent is going to be adjacent over opposite. In this case, our adjacent is going to be -1, and our opposite is going to be 1. All right, -1 over 1 is just going to get you -1. All right, now do the same thing with the next one, cosecant of 210. So I have 0, 90, 180, 270. I can stop right there because I know that 210 is going to be between 180 and 270. So I'm going to draw an angle right there. Right now, the reference angle to this, the distance from this angle to this segment to the x-axis is going to be 210 minus 180. Right, in the third quadrant, it's going to be the angle minus 180, and that's going to get you 30. Right, and then 30 degrees is represents one of our angles in a special right triangle. Right, so across this 30 is going to be a 1. Across this 60 is going to be a 1 square root of 3, and across this hypotenuse is going to be a 2. All right, this is on a coordinate plane. Put the signs appropriately. In the third quadrant, both x and y are negative, so I'm going to make square root of 3 and -1. And 1 negative. Cosecant was 1 over sine. If sine is opposite over hypotenuse, then cosecant is going to be hypotenuse over opposite. Right, my hypotenuse is going to be 2 over my opposite is going to be -1 of this angle right here, 30. All right, so it's going to be -2. All right, now I'm going to do the same thing with sine of -510. Once again, I don't really know where that is, so I'm going to find a coterminal angle. I'm going to go ahead and add 360 to this. All right, adding 360 to -510 is going to get you -150. Once again, it's a little bit easier to do this with positive numbers, so I'm going to add 360 again. All right, so that's going to get us 210 degrees, right? And we just had 210 degrees, right? So I'm going to go back here, and I'm going to use the same diagram, right? A lot of these numbers you see are going to get very repetitive, right? So I'm going to use this diagram that I just drew here with this with this 210, and I'm going to use the same angles, right? Now, we had found cosecant. Remember, cosecant is just the reciprocal of sine. So we have an opposite, a -1, and I have a hypotenuse of 2. So sine of 210, this is just going to get us opposite over hypotenuse, so -1 over 2 as your answer. All right. Let's do the same thing with this one, tangent of -1000 20, right? So again, I'm just going to keep adding 360 and finding coterminal angles, right? I'm going to keep going in circles until you find an angle that is a little bit easier to work with, right? So if you add 360, then you should get negative 660. All right, and then again, I don't like how that looks, so I'm going to do another I'm going to do another 360, and that's going to get you negative 300. Once again, I don't like how that looks, so I'm going to add 360 again. And here, if you add 360, you just get 60 degrees. This is a normal angle, right? We haven't seen one of those in a little bit, right? So I'm going to go ahead and draw this on the coordinate plane, right? 60 degrees is going to be right here in the first quadrant, right? So there's nothing really that you have to do here other than label this diagram appropriately, right? If this is a 60-degree angle, then that means this does form a special right triangle where the side across the 30 is going to be 1, the side across the 60 is going to be the square root of 3, and the hypotenuse is going to be 2, right? So then tangent, I know that the opposite is going to be the square root of 3. My adjacent is going to be 1, so it's just opposite over adjacent. So square root of 3 over 1, so that's just the square root of 3. All right, so a lot of stuff to keep in mind with this lesson, and this is probably as hard as it'll get before your test. So make sure you're comfortable with these. You'll have plenty of practice in Canvas.